Hello everyone, we are from Group 9 are going to present to you the communication principle. Do you ever wonder how we can send information to someone who is far from us? Or if the information that you want to send is your voice, how to make sure that what you are saying is understood by your friend? Well, I suppose you don't have friend, that's why you never wonder. The answer is simple, we use something called modulation to transmit the data to desired destination. So what is this modulation thing? It is a process that transforms a signal to a suitable format for transmission through a chosen medium. There are two types of modulation based on signal type, which is analog and digital. Both of them practically good depending on the application used. You can see how it basic work in this diagram. In this page, you can see how analog modulation work represented by the block diagram. Analog modulation is a process that modulates analog signal. There are three types of analog modulation, which is amplitude, frequency, and phase modulation. Each of them is a little bit different with another, but there are still the same analog modulation. Next, we are going to talk about digital modulation. Digital modulation is a process that modulates digital signal. There are three types of digital modulation, which is amplitude, frequency, and phase shift keying. Each of them is a little bit different with another, but there are still the same digital modulation. You can see how it work in the diagram below. Alright, so let's talk about amplitude modulation. Amplitude modulation is a fundamental modulation process in communication system. It changes the amplitude of the modulating signal according to carrier signal. The condition that need to be done is carrier frequency signal is far larger than modulating signal frequency. Baud rate refers to the number of symbol changes that occur per second. You can see how it work from this diagram. In this picture, you can see it clearer how amplitude modulation work. The above waveform represent the signal like your voice or song that you want to send. The middle one is the signal that need to be used to carry your voice signal to desired destination. The below one is when they both modulated and got sent to your friend. Besides amplitude modulation technique, other well-known modulation technique is known as angle modulation. Angle modulation uses modulating signal to change frequency and phase of the carrier signal. The concept is pretty similar with amplitude modulation. Let's say the above signal is your voice. The frequency of your voice will modulate with the carrier signal and will produce frequency modulated signal. The only difference with amplitude modulation is, this one change according to frequency while the other one change according to amplitude of the signal. Interesting, right? Next, we are going to look at radio digital modulation. For this case, the modulating signal changes the amplitude, frequency, or phase of the carrier signal in radio digital modulation, which is similar to analog modulation. There are three techniques used in digital modulation. First is amplitude shift keying, ASK. It is form of amplitude modulation that represents digital data as variations in the amplitude of a carrier wave. Second is frequency shift keying, FSK. It is frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. Lastly is phase shift keying, PSK. It is digital modulation process which conveys data by changing the phase of a constant frequency reference signal. In amplitude shift keying, the modulated wave represents the series of bits by shifting abruptly between high and low amplitude. On the other hand, frequency shift keying is the bit stream represented by shifts between two frequencies. And for the phase shift keying, it is the bit stream represented by shifts in the phase of the modulated signal. I know it doesn't make sense at this point. But anyway, let's talk about quadrature amplitude modulation. It is a method of combining two amplitude modulation signals into a single channel. This approach helps double its effective bandwidth. Which is better? Quadrature amplitude modulation uses both the amplitude and phase variations to boost the efficiency of radio communication transmissions in terms of phase, Quadrature amplitude modulation signal is product of two carrier signal that shifted by phase of 90 degrees such as cos and sin signal. Often one signal is called the in phase or I signal, and the other is the quadrature or Q signal. Last but not least, let's talk about comparison between analog and digital communication system. As you can see here, the transmission of analog data can only be described in analog signal. While for the digital communication system, the transmission data can be fully described as a digital signal. Analog communication is easier to get affected by noise highly during transmission through communication channel. But for digital, it gets affected by noise less during transmission through communication channel. The diagram below show what analog and digital communication system consist of.